So today in this video, we are going to once again uh, going to see logistic regression. So in the previous video, we have seen logistic regression, but according to me, it was not in that much detail, and for it was not that much in detail. So in this video, we will be looking each and everything related to logistic regression, and which and we will be trying to understand how the logistic regression is able to give us the output which is in the range of 0 to 1, and how it is able to classify the data points. So first we will be just recapping what we all studied in the previous video. Then later on we will be looking on the math part of it, and what all formulas and equations are there to get the classes to get the data points are of which class 0 or class 1. So let's start first. I will be recapping very fastly because this all we have completed, and we have to go to understand in depth. So first we will be just recapping what all we did in the previous video. So logistic regression is a type of supervised machine learning algorithm in which there is X and Y is given. That is why it is known as supervised machine learning algorithm. This point I didn't discussed in the previous video, so I am covering over here. And this is used for classification task. Okay, so data points. If the data is given set of independent variable, then you have to say whether the data points are of class 0 or class 1. So that is a classification task. And the main goal of this logistic regression is to predict the probability that an instance or a data points belong to class 0 or class 1. Suppose you are having a set of independent variables and you have to predict it whether it is of class 0 or class 1. So what algorithm you will use? You will use logistic regression. So that is the goal of this model. You can use any type of classification problem, but the main goal is to predict whether the data points are of class 0 class 1. So this is the main goal of this model algorithm, kind of a statistical algorithm. So logistic regression and linear regression, they both are a type of a statistical algorithm which analyzes the relationship between the set of independent variables and the dependent variable. So here also set of independent variables are there, like x, x1, x2, x3. It could be 2, 3, 4, or any numbers of independent variables, and the dependent variable is given, which is of categorical term, which is in category 0, 1, like that. So that is our dependent variable, which we have to find out from this algorithm. And any example, if I can give, so it will be the email is spam or not spam. So here also there is two class, 0 and 1. The spam, the email is spam or not a spam. So this can be classified with the help of logistic regression. So example also you can give. There are many examples, but let's I have written over here only this. So you can take any of the classification problem where there is two class to predict. Now let's go on to, so this all we have discussed earlier also. Logistic regression is a supervised machine learning algorithm mainly used for binary classification, where we use logistic function, also known as sigmoid function, that takes input as an independent variable and produce a probability between values between 0 and 1. Okay, is a supervised machine learning algorithm used for binary classification task. And here it is using a sigmoid function or logistic function. Okay, which takes a set of independent variables, which are our x1, x2, x3, and it's give the probability of that data point, which will be in the range of 0 to 1. Consider there if consider that there is a class 0 and class 1, and if the value of a logistic regression for an input is greater than 0.5, So the logistic function is giving the input is greater than 0.5, the value which is greater than the threshold value. Threshold value is the point where we decide after this number it will be class 0, or after this number it will be class 1. So our threshold value in general it is taken as 0.5, or uh, but in fine tuning you can adjust this number, but in the first place we use 0.5 as our threshold value. So if the value of a logistic function of an input is greater than 0.5, then it is going to the class 1. That data point or instance will going to the class 1. Otherwise, it will be going to the class 0. Okay, so this is the example which I have written so that you can understand it properly. The term regression in logistic regression can be misleading as it is an algorithm used for classification tasks. So here in logistic regression, regression term is there. Okay, but regression which we have seen, it was linear regression also in the first model of machine learning. So in logistic regression also there is regression. So it could be misleading for some of the students first. But while it shares similarities with linear regression, its primary application is predicting the probability that an instance belongs to a particular class. So the logistic regression main application is to find the probability of an instance, whether it belongs to class 0 or class 1. But in opposite, the linear regression was it we were finding the continuous y. The output which it was giving us, the y, it was in a continuous form. Like we were predicting the salaries of the students. But here we are predicting the classes. So they both are the problems statement which we are working, which will be it will be totally different in the regression, in a linear regression where we were predicting the salary of a student, and in logistic regression we are classifying the set of independent variables into class 0 and class 1. So let's move on to the next. Understanding logistic regression. It is used to predict a categorical dependent variable given a set of independent variable. So that only set of independent variables are there, x1, x2, x3, and we are trying to predict the categories of the that data points. X1 means the first data point, then the second data points, and that data point belong to which class. The logistic regression predicts the output of a categorical dependent variable. Therefore, the outcome must be categorical or discrete. The problem which we are looking is of to predict whether it is of class 0 or class 1. So it should give us the output in a form of categories. So it is a very means we have to get y in a 0 and 1 form. We can't get y in a continuous form. It will be totally wrong if we are getting the y in a continuous form in a classification problem. Okay, it can be either yes or no. Our class is yes or no, 0, 1, true or false. But instead of giving the exact 0 and 1, it gives probabilities between 0 and 1. But this logistic regression is not giving us properly 0 and 1, yes and no. It is giving the probabilities between the class 0, means the values are ranging from 0 to 1, which is a probability. Excuse me. Okay. So it is not giving us 0 and 1. It is giving the probabilities of which is between the 0 and 1. The logistic regression is much similar to the linear regression, except that how they are used. Linear regression used for solving regression problem. Yeah, which we have saw in a linear regression video. And here we are looking to how to we can classify the data points with the help of logistic regression. In logistic regression, instead of fitting a linear regression line, here we are fitting S-shaped logistic function, which predicts the maximum value 0 or 1. In the linear regression, we were looking to fit the best fit line, but in logistic regression, we are we are not fitting a straight line, we are making a S-shaped line, S-shaped curve, which is giving the probabilities which is in the range of 0 to 1. Because of this S-shaped curve, we are getting the values between 0 to 1, in the range of 0 to 1. Okay. The curve from the logistic function indicates the likelihood of something, such as whether the cells are. So the two classes which we discussed, spam or not spam, cancerous or not cancerous, mouse is obese or not, that all comes in the binary classification problem. Okay. Logistic regression is a significant machine learning algorithm. It has ability to provide probabilities and classify new data using continuous and discrete data sets. So our X could be in the means X means like X1, X2, X3 are there. X1 could be in a continuous form, X2 could be in a categorical form, X3 could be once again in a continuous form, but the Y would be in the class, means the Y our dependent would be in a 0 or and 1 only, not in the continuous form, because we are trying to find out the solution of the whether the data points are of class 0 or class 1. So the X variable could be continuous or categorical. It could be depend upon the problem statement. The logistic regression is significant machine learning algorithm because it is ability to provide probabilities and classify new data using continuous and discrete data sets. Yeah, that we have seen. Logistic regression can be used to classify the observation using different type of data and can easily determine the most effective variable used for the classification. In a logistic regression that we are, it is also able to identify which of the features are more important by the use of logistic regression. So we can get to know this as well by the logistic regression model, which of the data, which of the features are of more useful to the our problem statement. Now let's go on to the next topic, which is logistic function. The sigmoid function is a mathematical function used to map the predicted values to probabilities. It maps any real value into another value within a range of 0 to 1. Yeah, which we have seen the values which we are getting is in the range of 0 to 1. Okay. The value of the logistic regression must be between 0 and 1, which cannot go beyond this limit. So it form a S curve. The statement which we saw in linear regression, we were fitting the straight line, best fit line. But in the logistic regression, it would be the S-shaped curve. Okay. So because of S-shaped curve, we are getting the values in the range of 0 to 1. The S form curve is also called as logistic function or sigmoid function. If any of the person is asking in this question, S form curve in the logistic regression is also called as what? So you can say it is also called as logistic function or sigmoid function. So these two names also you have to keep in mind. These both are the same. S form curve, sigmoid function, logistic function. These all the three words represent the same thing, like S-shaped curve. Okay. The logistic regression, we use the concept of threshold value. Threshold value that I discussed, that the number which we are getting, which is the probability of 0 to 1, and 0.5 is taken as the threshold value, which is the base model. When we are fine-tuning it, we are changing that threshold to 0.6 or 0.4 according to our accuracy. Okay. So, but in the first, we are keeping threshold as 0.5 only. So if the probability is greater than 0.5, then it comes in the class 1. And if the probability is less than 0.5, then it comes to class 0. So that is what our logistic regression and how it is giving the classes, both the classes with the help of threshold value, which is it is keeping, and the threshold value, if the threshold value is 0.5, then and the probability of any of the data point is 0.6, then in the program then the class will be class 1. And if the probability of any of the data point is 0.3, 0.2, 0.4, which is less than 0.5, then it will be coming in the class 0. So that what it is written. I hope you guys have understood that point, means the under the term threshold value over here. Okay, so let's move on to the next topic, which there are both linear regression and logistic regression. So we have seen the similarities, and now let's see little bit of differences which are there in them, and main which differences are there that we will be seeing in the differentiate between linear and logistic regression. So let's see that one by one. Linear regression is used to predict the continuous dependent variable using a given set of independent variable. So in the linear regression, we were finding the continuous, y continuous, okay, in the linear regression. But in logistic, we are finding the categorical dependent variable while we are having the given set of independent variable. So here the main difference comes over y. Here y was continuous, and here the y is in a categorical form. Okay. Second difference is linear regression is used for solving regression problem. Regression problem like continuous y we are finding in the linear regression. Okay. And in the classification, we are finding out the classification problem, whether the data points are coming in the class 0 or class 1. So that is in the class 2. Means that's the point which is written over in the point 2. Let's see in the point 3 what it is. In this, we predict the values of continuous variables. So the main goal of our linear regression was to predict the values of continuous variable like salary, which we have saw in the linear regression video. Next will be and in the category, in the logistic regression, we are predicting the values of a categorical variable, whether the email is spam or not spam. So this comes in a categorical. We are trying to predict that the variable is 0 or 1. Okay, that is what is written. Let's see the fourth point. In the linear regression, we were fitting the best fit line, but in the logistic regression, we find our S curve. Okay, so this is also the major difference that you have to keep in mind. In linear regression, we are fitting the best fit line, and in the logistic regression, we are finding our S curve. And next point is the least square estimation method is used for estimation of accuracy. In the linear regression, which we saw, it was least square estimation method is used for estimation of accuracy. Okay. So I will be reading out more what it is LSE, least square estimation. The least square estimation is a method to apply linear regression. Okay. We apply linear regression with the help of least square estimation. It helps us to predict result based on the existing set of data as well as clear anomalies in our data. So our data is there, and our set of independent variables are there. So we are trying to predict our y with the help of the x which is given. And in our x, there will be some of the data points which are useful to predict our y, and some of them are not useful. So there are anomalies in our data, that what we can say in the other word. Anomalies are values that are too good or too bad to the true, or that represent rare cases. So with the help of two good or two bad values, we are trying to predict our y. So that is our least square estimation, which we saw in the linear regression. But in the logistic regression, we are having MLE as an estimation method, which is used to estimate, used for the estimation of accuracy. So in MLE, what it is a method of estimating the parameters of a logistic regression model. Parameters means the weights of a logistic regression model. Okay. We are trying to estimate, found out the weights of a logistic regression model. Okay. This estimation method is most widely used. Okay. In the classification problem, logistic regression, MLE is widely used. The method of MLE selects the set of values of the model parameter that maximize the likelihood function. So what it does is it finds the model parameters, means model weights that maximizes the likelihood function. So which of the data points will be coming, which of the data points are having the chances of falling in the class 0 or class 1. That is what MLE estimation. Okay. So in a linear regression, LSE, in least square estimation, and in logistic regression, MLE. So two different estimations are seen. Next is 6 point, which we will be seeing the difference. The output must be in a continuous value, which we saw in the linear regression, which is price, age, we were trying to predict. But in the logistic regression, we were trying to predict whether the data points are of class 0, class 1, okay, or the person is able to survive or not, like yes or no. So these two are the examples which you can use, means this, for this you can understand by this. So here the clear difference is there in the Y. Now the next point is 7. It required linear relationship between dependent and independent variable. In the linear regression which we saw, there should be a linear relationship. X and Y should have a linear relationship, which we saw in a linear regression. But in the logistic regression, if there is no linear regression, then also it is able to found out the whether the data points are of class 0 class 1. So there is no such requirement that a means the independent and dependent variable should be linearly have a linear relationship. In the logistic regression, that is not that much required. If there is no linear relationship, then also you can go with this logistic regression. Next is eighth points. There must be collinearity between the independent variables. In the linear regression which we saw, the data points were dependent of each other. So that what we wanted, the independent variable, they should be have a collinearity, which we saw in a linear regression. But in the logistic regression, there should be no collinearity between independent variable. If there is collinearity or there is no collinearity, the logistic regression is not affected by that. It will be able to give the answer of the data points whether they are class 0 class 1. So these are all the major differences which we saw, which was of 1, 2, 3. These all are the differences. So if you have not understood, go through this once again, and I am sure that you will be able to understand this. So terminologies involved in logistic regression. So let's see one by one what all these we have completed these all, but let's go through one more, because some of the terms here new are there, like log, odds, coefficient, and intercept, that I want to explain you. So let's start with the independent variables. The input characteristics or predictor factors applied to the dependent variable prediction. So independent variables are our x1, x2, x3, which are contributing to find out what is the y value. So x1, x2, x3 are there. That all are the factors which are helping us to predict the y. So that are independent variables. The dependent variables are the target variables in a logistic regression model which are trying to predict. So y is there which we want to predict with the help of the set of independent variables. So that is dependent variable. Logistic function. The formula used to represent how the independent and dependent variable relate to one another. So in the linear regression and in the logistic regression, both we were seeing that we are trying to find out the relationship between the both the variables. So the logistic function is contributing towards that. The logistic function transforms the input variable into probabilities value between 0 and 1. So the logistic function is the one who is transforming the input variables into the probability values between 0 and 1. So this is the very important function which is the which is converting the values to 0 to 1. Okay, so you have to keep in mind this line. The logistic function transforms, means it is changing the input variable into the probabilities value between 0 and 1. So this is a very important. So logistic function you have to keep in mind, which represent the likelihood of dependent variable being 1 or 0. So with the help of this function, the main function which is there in the logistic function, logistic regression, this is only contributing and trying to tell the input variable of the first data point belong to which of the class. Next is the odds. It is a ratio of something occurring to something not occurring. Okay. Something is occurring and something not occurring. There could be two possibilities, right? The email could be spam or it could be not spam. So there is, if the first data point is the email is spam, then that the data point it will be not a spam. So one character is one class is there for the first data point. So in that data point only you can't say that both the class are having 50-50 chance. If there is 50-50 chance, then your model is not working properly. So if the first data point is telling us that it is of class 1, like it is uh, the mail is spam, then you have to, then there will be, you are sure that it is not a spam, because the in the in the data set it was telling us that it is 1. So you can't say that it is 0. So there is something occurring and something not occurring. That is what odds. If the second data point is there and the second data points, the features of the X, they are contributing more towards that it is not spam or it is spam. So if it is spam, then you can't say that it is not spam. So there is something occurring and something not. That is what it is called as odds. I hope you are able to understand what is odds. It is different from the probability. Okay, as a probability is a ratio of something occurring to everything that could possibly occur. So in the probability, what we are doing, we are just checking the chances of what all things can possibly occur. And in the odds, something occurring to something not. If some, if the data points is spam, then it couldn't be not spam. So there are two different things, which is odds and probability. And in probability, we find out what all possible things can happen. So that is probability. Okay. So try to understand the difference between both the terms. Now let's let's see the log odds. The log odds, also known as Logit function, natural logarithm of the odds In logistic regression, the log odds of the dependent variable are modeled as a linear combination of the independent variable and the intercept. So dependent variables, which is our y, are modeled as a linear combination of the independent variable and the intercept. So dependent variable, which is y, and are modeled as a linear combination. Linear combination means the the space, the S curve is there. It is able to classify the data points into 0 and 1 with a linear combination. So with a single line, it is able to classify the data points. So that it what by the single line it is able to classify. So that is it could be a log or log odds. If this is not that much clearly able to understand, we will see it afterwards. Let's complete the others. Then we will be seeing what is the log odds. Coefficient. Next is coefficient. Coefficient is the logistic regression model estimated parameters. Show how the independent dependent variable relate to one another. So as we are trying to find out the relationship between the independent and dependent variable, so there are two weights which tell us uh, the relationship between the both the variables. So who tells us that? That tells us the coefficients. That tells us the estimated parameters. Okay. Now is the intercept, the constant term in the logistic regression model, which represent the log odds when all independent variables are equal to 0. Intercepts. Let me we have seen intercept in the linear regression as well. So the wait, I will be showing you in the linear regression. I'm going in that diagram is there. So this is the line which we were seeing in the linear regression. So this line was meeting over here. So this is the constant for that this line. So in the logistic regression also, if the data points are separable by the single straight line, if they are separable, so it is meeting to the y-axis at some of the data points. So that is the constant term, that is intercept. Okay. Now let's continue with the next term. MLE, which we have seen earlier, that only it is there. Let's see it once again. The method used to estimate the coefficient of the logistic regression model. What it is a method to estimate, to find out the weights of the logistic regression model, which maximize the likelihood of observing the data given the model. Okay, that only it trying to found out the data points are like more likely to be in which of the class. So that is what maximum likelihood estimation, and how it is trying to find out with the help of coefficient. It is trying to estimate the coefficient weights. So now let's move on to the next. How does the logistic regression work? The logistic regression model transforms the linear regression function continuous value output into categorical value output using a sigmoid function. So from earlier onwards in this video, we are seeing that the continuous y is changed into the range of 0 to 1 with the help of the sigmoid function. Okay, which maps any real value set of independent variable input to a value between 0 and 1. So who is doing that? Sigmoid function, logistic function, or S-shaped curve. All these three names belong to the same sigmoid function, logistic function, then S-shaped curve. These three terms are same only. Okay. This function is also called as C, or it is once more written logistic function. So I will be explaining you one by one. Here I will be. Okay. So the set of independent variables are there. Your x1 means x1 feature, x2 feature, and there could be many data points. Means there could be many rows in it. So there are m rows. Suppose there are m rows. So there were like how many features x1, x2 till xn it was there, and these all are the set of independent variables. Okay, and here the y is there, which is dependent variable. So suppose this was of class 0, this was of class 1. Okay, means these labels were given, it was of 0, this one. So 0 label represent class 1 and 1 label represent class 2. So like that all y is also given. I'm trying to explain you guys with the help of the mathematical mathematical expressions. Okay, so as we know here there are many features, so what we have to apply multilinear function. So this is the formula of it. This is the equation. So z is equal to summation of I is equal to 1 to n. I is equal to 1 to n means for the whole rows we have to do from 1 to how many? For how this means for all the features we have to do 1 to n. Our n is our features, right? X1, X2, X3 till n it was there. So till to all the features we have to do wi xi plus b, where xi is the observations of x. So there could be 500, 2000, how many with respect to the problem statement, there would be the observation. So xi is the observation. 1, 2 means there could be 500 or 6,000, any number of observations. So xi represent observations of x. Okay. Then W1 is the weights, W1, W2, W3 till Wm. So each of the features are giving the weights. Okay. So with the help of weight, they are trying to, with the help of the weight, we are finding out what is the relationship between the x and y. So some of the features are contributing more and some of them are contributing less. So this is what the real world data looks, and not all the features always contribute to its majorly. Some of them are not contributing and some of the features are contributing very high. So how we are able to find out with the help of weights, okay, weights of the coefficient. So these were the weight for x1 feature. This is the weight for x2 feature, and it goes on till the last for the last features. Okay, and b is the bias term. So the above term can be represented as, when we will write it as a dot product of weight and biases, z is equal to w dot x plus b. In general, it becomes this. So by this, we are trying to find out z. So if this all has been found out, means that is now available. So we will be using sigmoid function because we have to convert that continuous y into the range of 0 to 1. So we will apply sigmoid function. The formula for that is this: sigma of z is equal to 1 divided by 1 minus e raised to minus z. So with this function only, we are able to get the y in the range of 0 to 1. So here you can see 0.2 to till 1.0 means from 0 to 1, it is converting our y. So sigma of z tends towards 1 as means when it is over here at this area. Okay. So it is 1. Our probability is 1. And when it is minus of infinity, means it could be here, the data point could be here and from here to here. So it will be sigma of z will be 1. And when it is minus infinity, from minus to till here full, so it will be 0 or it will be negative. Okay. When it is means sigma of z is 1, so data point could be over here. And when the z is equal to minus infinity is there, then the data point could be lying over here. Okay. Let's move on. Then probability of being a class. So when y is equal to 1, when the y is equal to 1, so with the help of this sigma of z, sigma of z is the value which will tell that y is equal to 1. Sigma of z means here, when the data point is there, then it is 1. And how we will find out the 0th class? We will be subtracting it with 1. Okay. So suppose if the sigma of z was 0.8. Okay. So if you want to find out what is the probability of class 0, then 1 minus 0.8 I will do. So it will give me 0.2, right? The probability of being a class 0 is only 0.2. I hope you are able to understand how the probability of class is been found out with the help of sigma of z. So the logistic regression equation is there: p of x divided by 1 minus p of x. Probability of x divided by 1 minus p of x is equal to e raised to z. Okay. So what all transformations are, means what all logs and everything is applied. So we are getting this final equation. Let's see. So here log is applied to this equation, to this expression, to the numerator and to the denominator as well. And here z value is, we know the dot product of weight and biases, which is w of x plus b, which we saw over here. Z is equal to w dot x plus b. Okay. So z will become this, and here log is applied. Then final logistic regression equation will become probability of xi b comma w is equal to e raised to wx plus b divided by, because probability of x is this. Okay. And so here that it is substituted, and which we are getting finally 1 divided by 1 plus e raised to minus w dot x plus b. So final logistic regression becomes, so this is our final logistic regression. Okay. What all changes and that all is happened, that you if you are not I am not explaining that in detail because it will become too much difficult, and that is why I am directly just showing what is the final logistic equation. If you if someone is asking you, so you can answer this. So the final logistic equation is this: 1 divided by 1 plus e raised to minus w dot x plus b. Okay. Likelihood function for a logistic regression. Okay. Predicted probabilities will be p of x, b. Let me shift myself. Okay. Likelihood function for logistic regression. Predicted probabilities will be probability of x with base and weight is equal to p of x is y is equal to 1 and y is equal to 0 means 1 minus p raised to. Okay. So that we saw earlier when we how we are finding the probability of, if we are having probability of class 1, so we can easily find out probability of class 0 by just dividing it by 1 minus the probability of class 1. Okay. So if the likelihood function which we saw in the Visual Studio Code, the in the theory part, that likelihood function is also applied. So likelihood of biases and weight is equal to pi I is equal to 0 and p xi raised to yi 1 minus p xi raised to 1 minus yi. Okay, so this is the likelihood which is applied to the weights and biases. The natural log is applied on both the sides. So over here also log of likelihood biases comma weight, and here also I is equal to 1 to n to all the features it is applying, we are applying, and yi is equal to log of pxi plus 1 minus yi log 1 minus pxi. So here also you can see log, and here also here log is there. Okay, then we are trying to do calculation. So this calculation is little bit difficult to understand, but I will be trying to explain you this also. So here yi is this is same sigma of here, everything is same. This term is also same, plus your 1 multiplied by this log this multiplied by this. So it will become log 1 minus pxi, and this it will be multiplied by this. So minus yi, then this term. Okay, so this line is completed. Then what they have done. So this term is written over here, which we can see. Shuffling is done. And as we are applying this summation to I is equal to 1 to n to everywhere. So here also we have written, and here also we have written. So this will be there in each and every term. And this log p of xi, here minus is there. Minus means division. Minus and division goes hand by hand. So divide by log 1 minus pxi. So yi, what's common here? So yi is written outside. See here, log p of xi and log 1 minus p of xi. So this was in subtraction. So the subtraction is there, so we can write in division also. So yi was common, so yi is written outside. Okay. So this line is also completed. Then this minus summation of I is equal to 0 to n minus log 1 minus e raised to. Now p of xi value is substituted. Okay. And here also p of xi value is substituted. Okay. So after that, this line we are getting. Yeah, then it is completed. Then there is nothing to do over here. and here it become positive and nothing is over there. So this all, if you are not knowing, then also it is okay, but you should know what all the main things are there, which we have understood in the theory part. This is all just the equation. This is all just the mathematic part. So if you are not able to understand, then also it is okay, but it was there. So I am just trying to explain you. So gradient of the log likelihood function. Gradient of the log likelihood function. So we were applying likelihood function also. So with the help of gradient of log, that will be done. So how the it can be done in a mathematical way. In behind the scene, what all things are going on, let's see with the help of the this equation and how they have found out. Let's see and try to understand. So let me go to whiteboard. Yeah. So gradient of the log likelihood function. This letter, Greek letter is there. Then likelihood of base, comma, weight divided by this Greek letter. Weight of j is equal to summation of I is equal to n. Your one will come. Let's check. Wait. Let's have a. Okay, so I is equal to n is only there. I is equal to n. So your one, this was the final logistic regression. Yeah. So final logistic regression, which is the written 1 divided by 1 plus e raised to w dot xi plus b. Same thing. Okay. And here, in place of this, xij is written. Okay. So this all become probability of xi with base and bias and weight. Okay. And xij plus this term. So in the next line, minus was there, it came inside. So yi minus probability of this thing, p of xi, comma, biases and weight, comma, xij. Okay, because xij is common, so written one time, and what was the difference, which is written in the bracket. So this is how the researchers have applied gradient of the log likelihood function. Okay. This all mathematical equations, you guys, if you are not knowing, then also it is okay. No one is asking all these things. But what all are the main equations of logistic regression that you have to know? And yeah, and what all the main things were there, which I have discussed earlier. And this was all the mathematic part, which I wanted to show you how they have done with the help of gradient of the log likelihood function. So yeah, this was all about that. And this all in all the mathematics terms, no one is asking, and how you can solve all this in this much depth, no one is asking. And whatever is asked, no, that I have completed in the theory part, and that all only the main things are there in the logistic regression. So if you're not knowing this all calculations and how they have found out, the researchers and scientists have found out, so it is okay. There is no such issue if you're not able to understand. So be calm and just what is all the main things which I have discussed in the Visual Studio Code, that all you have to know, that I have covered it in a detailed manner. So you can go all the important part of it, and the one which is in a greater depth, all the calculation part, that if you are not able to understand and you are not covering, then also it is okay. Okay, so that what I wanted to say. So let's see the assumptions of logistic regression. What all the assumptions are there? Okay, the assumptions for logistic regression. The assumption for logistic regression are as follows: independent variables, each observation is dependent of the other, means there is no correlation between any independent variables. So in the linear regression, there was the linearity which we were trying to find out. The x and y should be of, they should be separable by the single line. But here what it is overwritten, each observation is dependent of the other, meaning there is no correlation between any input variables. The x1 data points, they are not dependent of each other. They are independent and they have scattered in the graph. So they are not dependent on each other. Okay. So our x should be, there should be no correlation between them. These all are the assumptions. And second, it should be of binary dependent variables like yes or no, 0 and 1. This type of y should be there. These are all are the assumptions of the logistic regression. Okay. Linearity relationship between independent variable and the log odds. The relationship between the independent variable and the log odds of the dependent variable should be linear. Independent variable which is of x and log odds of dependent variable. Something happening to something not. That what is log odds. Should be linear. Okay. So these are the assumptions. Fourth is no outliers. There should be no outliers in the data set. In the logistic regression, if the data set is having lots of outliers, then it is not following the assumptions of logistic regression. So you have to try out some other model. So there should be no outliers while you are using logistic regression, that you have to keep in mind. So these all assumptions you have to take into consideration while building the logistic regression. So you have to keep in mind all this. The sample size is sufficiently large. And this also box should be ticked, like the data set should be large. If your data set is small, then you can't go with the logistic regression. Okay. So these are all the assumptions. No correlation should be there. Then your y should be of two types, like yes and or no, and the relationship between the independent and log odds of the dependent variable should be linear. Okay, and there should be no outlier. And the last is the data point should be sufficiently large. So these are the assumptions that should be seen. And if all these assumptions are met, then you should are good to go with the logistic regression. Now let's move on to the last part of the logistic regression. Types of logistic regression. On the basis of categories, logistic regression can be classified into three types. Binomial. In binomial logistic regression, there can be only two possible types of the dependent variable, such as 0 and 1, pass or fail. Okay, the y should be of two types, 0 and 1, pass or fail, spam or not spam. That comes in the binomial logistic regression when you are having only two class. Then in second is multinomial. In multinomial logistic regression, there can be three or more possible unordered type of dependent variables, such as cat, dog, or sheep. Or if the features are there, x1, x2, x3, and if you want to say with the help of x1, x2, x3, whether the animal is cat, dog, or sheep. So that type of problem becomes a multinomial logistic regression, which I have not, means this multinomial, ordinal, this type of problems I have never seen carried out by the logistic regression, but these are also rarely used sometimes, so it is written. So I'm explaining you. Generally, this only first problem is majorly solved by the logistic regression, and it also works very well in the first binomial logistic regression. And when the all these assumptions are met, then the logistic regression is a very much powerful model with respect to classification of the data points. Then the third is ordinal. In ordinal logistic regression, there can be three or more possible order types of dependent variable. Here we are trying to say whether the data points are of come in the low, medium, or high class. So if there is order, means low is the in the bottom, and medium is above the above bottom. There is second, which is medium, and high means which is the top class. So your order is there. This type of problem, if you are solving with the help of logistic regression, then it is called as ordinal logistic regression, because your order is there. A high comes at the top, medium is below the high, and low means which is at the bottom. So this type of problem is solved. If you are solving with a if this type of problem is there, then you should say it is an ordinal logistic regression. So these are the types of logistic regression. So this all we have seen in the logistic regression, and I hope you guys have understood what I have explained you in. And if you guys are having any difficulties to understand, so you can also comment. I will be reading all of your comment. And if you have not seen the previous video of logistic regression, I will be also telling you to first see out the first video of logistic regression, so that your introduction, there will be some of the knowledge from where you can be gather the base knowledge. So over that you can build this all other knowledge which I have shared you. So please consider giving me a like, share, and subscribe my channel. And I will be coming in the next video with the other topics from the data science. So bye bye, take care, and happy learning.